I want to welcome you to the YouTube channel for ATEC. We're going to be going over the fundamentals of automotive evaporative emissions, something that's pertinent today to get those monitors to run. Okay, we're going to do the fundamentals of automotive evaporative emissions, and the first thing you got to realize is that's EPA. And what we need to look at is this. The fuel vapor system is one of the most neglected parts of the vehicle's emission system, according to the Environmental Protection Agency. And I would agree with that. Most of us don't test the system at all unless we really have to. Factory emissions tests have determined EVAP system with a leak as small as 20 thousandths of an inch can yield a 1.3 grams of HC per driven mile. I'm just reading this for you. And it's over 30 times the current allowable exhaust emission standard. That means this thing can cause a lot of problems if it's leaking. In addition, HC emissions failure EVAP system also wastes fuel. Fuel economy goes down. Your customer might complain of that. And often the customer complains of gasoline odors. You have gasoline odors in the vehicle that a customer can complain about that can be related to the EVAP system. So as the laws are changing, we need to make sure we understand how the system works and be able to test it correctly. Okay, when we're talking about the types of EVAP systems, back in 1970, when we started doing some of this one of the things I want to make sure you understand is the carbon canister was out underneath the hood. And those were systems not ECM controlled. We had a thermal or a ported vacuum switch that we'd use, so we would prohibit the systems working during a cold start or during warm-up. Now, as we went farther, the pre-OBD2 systems used a ported, again, talking about a ported vacuum switch, or a duty cycled vacuum switching solenoid. Those were the other systems you might see. This type EVAP system provided a little bit more precise control than the other systems that we've seen earlier. It cannot check the system for leaks. All it would know is if a purge flow happened. So OBD2 wanted to enhance this. They wanted to check the system out for leaks. So there was either a non-enhanced or enhanced form. Those were the next things that we will be talking about in this class. On the non-enhanced system, just like we were just saying, they could determine the purge flow, but they couldn't check for leaks. These were only installed on the 1996 and 1997 model years. They did not include a readiness monitor. A readiness monitor would say that the monitor has run and completed. There were no readiness monitors on it. So the next thing that the EPA wanted us to do was come up with an enhanced system. They can detect the purge flow and system leaks. They have vacuum switches or pressure sensors they could use. We have a vent solenoid, a vent valve, or a closed canister valve can identify them. So some of the systems there. We also noticed that the canister was usually monitored or moved to the back of the vehicle instead of underneath the hood to keep from having heat affected. All systems had a readiness monitor. That would be under mode 1 on your OBD2 Scantool. The enhanced EVAP systems were required on all 98 and newer model years. On the enhanced systems, the enhanced EVAP system, there are various types and they have different ways they do the system, but they achieve the same goal. Depending on the year, they were trying to find out if you had a leak of about 40 thousandths or 20 thousandths. Later cars, 20 thousandths. Earlier one were 40 thousandths. The system actually performed the test for either lowering the pressure and thus you had a vacuum in the system, or they wanted to increase the pressure with a pump. And some of the earlier Chrysler products, believe it or not, would actually do the test key off. You would drive the vehicle, let it sit, and they would go out and do their own test on the system with the pressure, building pressure in the system with the key off. So there's different ways they did it, but they achieved the same goals. They were looking for a leak, whether it's 40,000 or 20 thousandths. Okay, methods of testing the enhanced evaporative emission systems. The first one was vacuum decay. And basically vacuum decay had 3 components. And one of the components, this is my charcoal canister that I told you is going to be moved back to the back side of the car. We also have a canister vent. The canister vent is always open, allowing air to flow through at certain periods of time. But when we're doing this vacuum decay test, we would close this unit here, and then we would start to open up the EVAP canister purge solenoid, which is out underneath the hood. This is going to be near the tank. This is going to be out near the intake manifold. Now keep this in mind, we're going to call the canister vent the back door. We're going to call the EVAP canister purge solenoid the front door. Now what we're going to do at that time, we're going to put a vacuum in the system, and we're going to watch for a pressure decrease in the system. So your pressure sensor is usually on the top of the tank somewhere that you're going to be using. So those are the three things we're going to be using. And as the purge solenoid is going to create a vacuum in the system by allowing vacuum to be applied there. And we're going to, if this is closed, we should see a change in pressure. We're going to hold it for a period of time, and then we're going to see if it holds that pressure. If it doesn't hold the pressure, then that would indicate we have a vacuum leak in the system. Now, the other system that came along was a fuel tank pressure canister vacuum on the Toyotas and the Hondas. They do it a little bit different. They could isolate the fuel tank from the charcoal canister. So they would isolate the fuel tank from the charcoal canister. They would split the system up. So the Toyota uses two different versions of this. The one was non-intrusive, and the other one was called intrusive. The first one was used between 1996 and 2002, and the second one's starting to be phased in 2000. You got to keep this in mind, is not all the systems are the same. You might have 1 year and have a different system on it, and you might be pick up another car, another part of the system would be on another model. So you always got to make sure you know the system that you're working on when you're doing your diagnostics. Okay, the next method of enhanced evaporative emissions was a leak detection pump. This was used on the Audi, BMW, Chrysler, Hyundai, the Mitsubishi products that were labeled as a Chrysler product, Volkswagen and Volvo. This had a little pump that was operated, and it would pressurize the system to check for a leak. They worked very well. In 2000, BMW, Hyundai, and Mazda introduced a diagnostic module for tank leakage, and they had a DMTL pump to pressurize the system. That was designed by Bosch. That was one. There's a little bit of issues with it, but it still did a good job. In 2005, Toyota introduced a vacuum pump module key off system. So these would be the systems you would have with a leak detection pump. They're either going to have a pump to create a vacuum, or they have a pump to create a pressure in the system, and they're going to test for leakage at that point. The next enhanced evaporative emission system was a natural vacuum leak detection thing. If you look at this system, it measures the fluid and vacuum pressure in a closed container. As the temperature increases, the pressure increases if no leaks are present in the system. If you had a leak, the pressure would not increase. The system primarily was used on the small leak system, the 0.020 inches on the system. First appeared in 2002 model years, Chrysler, Ford, GM, Honda, and there might be another couple of companies that started this. And they use variation system. Not all of them work the same. My Dodge uses the eSIM system. That's a little bit different. To inspect repair, you must be able to identify what system is on the vehicle. If you do not know exactly what system is on it, you're going to misdiagnose an EVAP leak on the system. So you want to make sure to look in the manual and determine the system you have on the vehicle before you start trying to diagnose it. Okay, the EVAP's function is to reduce the amount of vapor escaping to the atmosphere. And if we look at it, the pressure in the tank is going to have the vapors in there, and they're going to go out and they're going to go into the EVAP canister. Now, the EVAP canister is activated charcoal in here, if you ever taken one apart. And the whole idea is it's going to act as a temporary sponge to absorb and store the fuel vapors. The next thing happen is if excessive pressure comes up here, what will happen is it will vent the vapors from this line here out to the canister vent solenoid into the atmosphere. So the whole idea is until the engine can use the fuel vapors, they're stored in this canister here. And that makes it a little bit easier for the process. If I store them here, I'm not leaking it to the atmosphere. Now, that's one. Let's go over to the next slide here. Under favorable conditions, the powertrain control module, all right, will turn EVAP purge solenoid open. So when we're doing this purge solenoid up here, it will be able to pull a vacuum in the system from the intake manifold pulling through it. The next thing happens is the vent line on the canister vent up here, if it's open, which it normally should be, it's naturally open, it's going to draw fresh air in the vent line to the EVAP canister. So I'm going to draw fresh air, come back into my EVAP canister here. The stored air-fuel mixture inside the canister right now will flow through the EVAP purge solenoid. As it's coming out, it's going back through the EVAP purge solenoid into the intake manifold and will be burned during a normal combustion process. It's what it says up here, and that's what happens. So what happens up here, we're going to be able to pull this vapor out of here, go through the process, add additional air coming through here to create a pathway or a pathway of pressure up here. We're going to create a negative pressure, atmospheric pressure on this end. We're going to be able to pull the vapors from the canister itself, bring them into the engine, and we're going to burn them under normal combustion. That's the whole idea that needs to be done with the EVAP functions. Okay, we're going to look at the components again. We've been talking about that, but the first thing is we got our canister for holding the vapors in the system to prevent them from getting vented to the atmosphere. The other thing we've got is our purge solenoid. Again, what we're going to call that is our front door because it's toward the front of the car. We also have our canister vent solenoid. That is our back door in the system. It's always been taught that way, back door, because it closes up here. It's when we want to create a vacuum in the system. It is normally open, allowing fresh air, as we were just talking about, fresh air to go to the EVAP canister. We have a fuel tank pressure sensor, which is normally on the top of the fuel tank. Different car companies have different voltage ratings on them and whatever, but that's up here. The other thing is we have a service port. Now, if you'll notice up here, I'm going to do this real quickly. This has already been opened up. This thread in here is going to be a left-hand thread. I'm just going to do this ahead of time. We're going to talk about it later. But that's a service port. Normally, the service port itself would look like this. It would have a green cap to it. Now, the newer cars don't have the service port, so that's gone. When that happens, you're going to have to be doing something. I'll just get ahead of myself a little bit. Sometimes you'll have to take a yellow cap like this. By the way, BMW and Minis have a different style. Theirs is black. You would put this over the cap and allow you to check here. The other thing is, if you have that problem, you also can go up here to the canister, not canister, but to the EVAP purge solenoid and actually hook up to one of the lines here and pressurize the system. So there's a couple of different ways you're doing on it. Again, the service port is usually going to be green somewhere out in the vehicle. What we're going to do is there's a Schrader valve in here that needs to be replaced or taken out, and that's going to be a left-hand thread. The funny thing about it is the connection to the hose is right-hand thread, but the inside you're going to use the little Schrader valve tool to pull it out, and it's a left-hand thread. So make sure you understand that, because I've seen a lot of guys damage these over time. Okay, we're going to look at the plumbing system on this particular EVAP system. If your number one is going to be your EVAP canister purge solenoid, all right, if you're looking at it. Number two is EVAP canister. You want to look at it there. We've got number three is a fuel fill neck and gas cap. And by the way, on EVAP systems, that can cause an issue because you can create a leak right there. I have fixed a few cars there lately. There's a rollover valve, so when you actually roll the vehicle over, which we never happen, you're supposed to have the wheels on the ground, not up in the air. And if you roll over, you're going to have a fuel tank near the fuel tank pressure sensor. It's going to shut off fuel from being dropped out of the vehicle at that point. We have the fuel tank up there. We have the EVAP canister vent solenoid. We got the vent hose and pipe, and that's number 7. Number 8, it's a vapor pipe going to EVAP vapor pipe, and there's a purge pipe, which is there also, that's number 9. And 10 is your EVAP service port. Now keep this in mind, not all cars have the service port. I have learned over a period of time, some of the European cars that you're working on, you might have to have a little adapter to actually service a vehicle through that service port. I've got one for an Audi that I just had to do recently, so we're looking at those issues. So that might be a description of the system that you have on your car. It's a good idea to look at it and see what's going on. You might, in your information, get a pictorial or whatever they're going to diagram of the system. We had the plumbing system up there. We have it again, but we have pictures of each item. It makes it a little easier for me to understand. One of the first things we want to look at, I'm going to pull this up. One of the first things that got a purge solenoid, notice it is normally closed or off. So this is the front door in the system. It is normally closed. We can go over and we're going to look at our service ports there. We might not have a service port, and if you notice, it's hooked out into one of the lines that goes to the purge solenoid itself. If you go down below there, there's my charcoal, and they got charcoal carbon canister. It's charcoal, activated charcoal there. If I go to my vent solenoid, down at the bottom, that's my canister vent solenoid. It is normally open, and it is off. It's normally, that's position. So the front one is normally closed, the back one is normally open. So keep that in mind. That allows fresh air to flow through this system in order to help purge the fuel vapor from the canister when a vacuum is applied on the other end. Always know the pressure differential. We're going to apply atmospheric pressure on one side and vacuum the other. We're going to be able to pull the vapors out of the canister. Now, if I go over here, you look at, there's the intake manifold and a throttle plate up there, and what I really wanted you to see is this. There's a fuel tank pressure sensor. It is normally located on top of the fuel pump on a lot of the systems we're looking at with the fuel pump module. Where the fuel pump module is where you got the filter, you got the pump, and you've got everything else in the sock all in one component. You put it up together. And then they've got that up there. So if you notice in the center, that is, if we look at it in the center, that's your vent line. And where does that go to? That goes back over to the carbon canister or the charcoal canister. So those are all the items that would be inside. Another look at it, but it gives a good idea. If you're a student or you're teaching your students, it is a really good idea for them to understand how this flows through. This is a really good example of how you look at the system versus what we did before. But it's just something I like using a lot better. We're going to go over and talk about the fuel pressure sensor next. Okay, the fuel tank pressure sensor is a primary sensor you're going to use on the system. It measures the difference in pressure between the fuel tank's pressure and the outside air. There's a 5-volt reference to it in the ground, and the feedback sensor is usually going to vary somewhere, if you're looking at voltage, somewhere between 0.1 and 4.9, depending on the application. Not all OEMs do it the same way. The fuel tank pressure signals varies inversely. Big word, which means is instead of high would be higher pressure, low voltage up there, it's backwards what we normally would think. So low voltage indicates high pressure, high voltage would indicate low pressure. Well, on a map sensor, that would be just reverse of that, so we know what's going on. And the GM's key on engine off voltage is going to be about 1.5 volts, or minus 17.5 to plus 7.5 inches of water. Now, inches of water is a little different. We're going to be using a manometer, or we're going to use water on our particular smoke machine. It's going to be able to set for that readings we look at. But on top of that, depending on your Scantool, your sensor can read pressure of inches of water, millimeters HD of mercury, or a pressure reading, PA. So we're looking at pascals is what you would be looking at. Sensor should be tested with a Scantool. First thing you should do when you do an EVAP system is check this sensor to make sure it reads within specs. That's the first thing you should always do, determine what's going on. Now, that determines if it's reading correctly. The next step is you're going to determine changes of pressure in the fuel tank and when the purge is working. So that sensor is primary for us to know if we have a pressure or a pressure leak, or we have a vacuum leak, depending on the system we're working on. So let's look at our next slide over. And this is the eSIM system. This happens to be on a Dodge. This is 2017. Notice I have the eSIM switch, says it's open. We got our fuel levels at 96%. Now, if we're testing an EVAP system, they probably do not want it set at 96%. They probably want it set somewhere between 80 and 85% or less. But it's got to be with maybe a quarter tank and up, a little bit different. Notice my fuel tank pressure on this system is minus 109 PA, and my fuel tank vapor volume. It's interesting. They actually measure the vapor in the tank. Now, you would have more vapor on a hot day than you would do on a cold day, so it's something else to look at. If I go up here, I start this vehicle up. Now, this vehicle is warm, all right? So I started up there, and notice my fuel tank pressure went to minus 967 kPa, or excuse me, PA. My fuel tank vapor, let's go back to that. My fuel tank vapor was 3112. It hasn't changed much up there when we fired it up. My purge airflow is 0.2 grams per second. My purge duty cycle is 32. And if you look at it, purge mode is learn, is looking at a system, and it does say learn. It's learning the system. And we have a purge vapor ratio of 0.27. This is some of the things you might be looking at on your system. And this is pertinent for you to look up reference material in the diagnostic strategies or how the system is working to understand what's going on. There's a lot of data kicking out here just to look at on a purge system. Now let's go over and we'll talk about the vent system next. Okay, the canister vent solenoid's here. It's the back of the system. It allows fresh air to go through at atmospheric pressure. It's normally open, okay? PCM closes the vent solenoid in order to check for a leak in the system. They'll close that and they will apply vacuum on the side up here to see a decrease in vacuum. That's how they will do that on the purge solenoid, or they will take an LDP pump or the DMTL pump and apply pressure to the system and look for a leak. Now, the vent solenoid is also the back door. You've heard me tell it the back door because it's always in the back of the car, and that's what we're going to be looking at. So we're wanting to be able to use this as ability to purge the canister itself. So let's talk about a few other things. The EVAP canister itself, I will tell you, I have never found a code for that. But you will find sometimes when you look at it, if this gets restricted, it can cause false codes where you're looking for a leak when you don't have one. I've seen this a couple of times. So it's granulated activated charcoal. And what its job is to store those vapors. Now, it's granulated, which means there's a lot of surface area up there. It's almost like a powder in a sense. There's a lot of surface area up there, and it has this vast amount of surface area to pull that vapor in and store it. Now, it's increased surface up there. I have heard people say it's like a football field, but I don't believe that one. But I believe it's quite large of an area can come up. The other thing about it is if there is dirt pulled through the canister vent solenoid, you're going to have an issue with this. And that does happen out where I'm at in Kansas and Oklahoma and Iowa, in Nebraska, whatever it is, when their farmers are up there, they'll pull up and they're getting their crops in, and they will pull some of the stuff into the system. The other thing is Ford will tell you on the canister vent that they want to make sure you check it and making sure it's clear, because spiders will make webs in there and cause a problem. That's another thing you're going to run into, which will affect the system. Now, fuel vapor is stored in the canister and it's held there till you have the ability to purge it and make it, run it through the engine to burn it. Now, the other thing about it is we're going to be looking at the flow through the system. If the canister vent is closed, again, we're going to be able to check for a leak. If it's open, which it should be, if it ever is damaged, keep this in mind, where there's a restriction here, it will affect your readings on your Scantool. And sometimes you'll get a false code. It'll say it's pressure or say it's vacuum, when in reality it's something in the canister vent will cause you an issue. Now, as we go forward on this system, we look at our service port. Now again, you've already heard me tell you that not all cars have it. Service port's up here. You're going to have a little tool, and I don't know if you're going to be able to see that, but this little tool up here is a little bit longer. It's a left-hand thread up there. You want to pull that out when you're servicing this up. You also want to put it back in correctly and don't damage it when you do it. I've seen a lot of guys damage the Schrader valve in there. Now, it normally has that green cap that we're looking at. I showed you a little bit before. If there is no service port, I've already put this up here, but if no service port, what I would do is take this nice little yellow cap, if I can do it right, and there we go, and put the cap over there, and I can actually service through here. If I can't service it through there, I'm going to be able to take one of the hoses off the purge solenoid, the one from the tank, and be able to apply smoke or apply pressure back to check the system for a leak this way. And if we're looking at that process, now again, we're only going to be looking at a 1 psi of pressure in the system. Too much pressure is going to damage something. So you're looking at it again, no service port. The other thing I wanted to make sure everybody knows, that's a yellow one for most of the cars, but if you got a BMW or Mini, there might be a black one. If you look at the top right-hand side on the slide there, you see where that green service port is, and you see the tools for doing the process. There's a little tool that is hooked on right here that will allow you to hook up my hose into the system. Now, if I go to my next one up here, the newer systems don't have gas caps. So you're going to have to buy some kind of tool to go in and be able to diagnose it right at the filler neck. And a lot of times what they have is tools that you're going to put in there and do it. So there's this example, Autoline Pro there. The only thing I'm going to tell you if you use this, I've only had to use this twice now. Not too many cars in my family have this, but here's the deal. You want to make sure you buy extra ones of these. These are these little, nice little self-adhesive up here. If these are not there, you're not going to get a good seal in the system. So always make sure. There's some that comes in the case, but buy you some more. I've got like 15 or 20 of these I've bought over the period of time and never have had to use them since then. But that's something else you're going to look at. If we go over to our next slide, this is EVAP purge solenoid. Now, kind of been talking about this. One of the things you look at is located between the intake manifold and the EVAP canister in the line. So if you notice, it's between the intake manifold and it's between the carbon canister. There's my in, this is coming out in the process. So if you're looking at it, you want to, it controls the vapor flow or the negative pressure being applied to the system to pull that vapor out of the carbon canister or the charcoal canister. Pulse width modulated. These are not on all the time like the older systems were. These are pulse width modulated. Remember the earlier systems were thermal switches, whatever, and they just turned on, they stayed on, they purged most of the time. These are duty cycled. So if I was looking at it, I would have a duty cycle here. I can use my multimeter, I can use my lab scope, I can check this for a duty cycle. The other thing while we're here, there is problems with this. If I have this break down, this carbon canister, I call it carbon canister, but the EVAP canister is here. If that breaks down and the charcoal gets loose in here, it will be pulled up into line here. So one of the first things you want to do is take the lines off here, apply vacuum to this to make sure it seals. Now when it's running, you know, I do both lines because there is sometimes some will seal one way and it won't seal the other. Sam does it one way or the other at some point, he's here. And the other thing is if you want to do this when you also want to make sure when the engine's running that it's pulling a vacuum when you turn it on. So get your Scantool, activate the purge solenoid and duty cycle it up and you should see an increase in vacuum on the system. If you don't, that would indicate you have a problem on it. So you would probably hook up the line going back to the tank, make sure that you're hooking up there with your gauge and make sure you can pull a proper amount of vacuum in the system. There's a lot of things you're looking at and this thing is not as simple as you look at. You're going to be basically becoming a plumber on the system. So the solenoid is also used again. We're going to, if I close this canister vent and I open this up and I pull my system up, I'm going to be able to pull a vacuum in the system and that's how we're going to determine on the vacuum decay systems if we have a leak. The vacuum should stay there for a period of time. If we lose it quickly, we have a leak in the system. That would be, if it's quickly, it's a big leak. If it's slow, it's a slow leak. So we're looking at the system and diagnosing what we need to do. Now, that's what we're looking at on the system. We'll look at it. If we will go over, we're going to look at the tank next. Okay, we're looking at our fuel tank here, and if you notice at the top of it, they have the air and hydrocarbon HC vapor mix. Now remember a little bit before on the one slide I had with the Chrysler or the Dodge van, it actually had the vapor in the tank. They calculated it. So we're always going to have some vapor in the tank at the top, depending on the temperature. Now, if I go over to my next slide over here, it's hydrocarbon vapor. It's from evaporated gasoline, meaning that it has changed from a liquid state to a vapor. Increases in temperature because the state of change affects at the rate it occurs. So if the engine's hotter, you're going to have more of this happening. Engine exhaust heat can vaporize gasoline during engine operation. You're looking at gasoline evaporation continue when the vehicle is parked after being driven. That always happens because the fuel is warm in the tank. So it remains hot. As it remains hot, it's going to create a vapor. Even when the vehicle is not driven, it says up here gasoline evaporates. That's true. If you don't believe me, just take a gasoline tank, put it out, and just let sunlight get on it over a period of time. You will see it expand. And if you take the cap off of it, you'll see the pressure go away from there, like you're doing when you're getting ready to mow the grass. The rate of expansion increases as the temperature rises during the day, which heats the fuel tank. So that's part of the reasons why we have the engine off natural vacuum system also. Now, I will also tell you, just for another route up here, the same thing happens on a GDI engine real quickly in the fuel rail. As the engine gets hotter, as it sits there, the pressure will increase. Same thing that happens. Okay, we're going to look at the output controls that you have available through the Scantool. Most of them are out there. There are some of the factory Scantools going to have a little bit more. So on the purge solenoid, you look at it, it has engine output controls EVAP. So we're going to be able to control the purge solenoid, and we're going to activate that when normal command is none, because it's normally a closed unit. As remember, that the front door is always closed, the back door is always open. So we will increase it by a percentage of usually 10% at a time to up to 100%. Now the system remains commanded until the tool is canceled by the tool, or the fuel tank pressure exceeds 24 millimeters of mercury or 12 inches of water. If you exceed that, it will automatically shut the system down as protection to keep from having damage. The other thing is you got to purge and seal, and it enables two functions. The first thing is it's going to allow you to increase or decrease the changing the duty cycle to the purge valve, and command the vent, canister vent valve, command it on, which means there's no venting, which means you're going to be able to pull a vacuum in the system or pressure. Normal command of both valves is none, and if you look at it, and we're looking at it, you can increase or decrease the EVAP purge solenoid, again, by the same amount of 10. When activated, you're going to command it up, and you're going to be able to create a vacuum in the system. Now, here's the deal. It will stay that way until you're commanded by the tool, or you exceed, again, 24 millimeters of mercury or 12 inches of water. The last one is the EVAP solenoid there. You activate the vent solenoid. Normal command is none, which means normally it's closed. You're not going to open it up. When commanded on, it flips to, they call it non-venting, so basically you're going to close it, so it's not venting to the atmosphere. System remains in that state until you're canceled by the tool, or the purge is greater than 0%. Okay, then you're doing this manually. And if the fuel tank pressure exceeds 24 millimeters of mercury or 12 inches of water. So there's some ways and there's some guidelines. So here's a bit. If you're teaching this with students and they decide they're going to put extra pressure in it, they're going to shut the system down. And I've seen kids do it a lot as they're going to classes. So that's where we're at. There's some output controls you can use. Okay, the weak vacuum test checks for large leaks and blockage in the EVAP system. The test will close the canister vent solenoid by turning it on, and open the EVAP purge solenoid by turning on it also. When the purge solenoid opens, engine vacuum is applied and build up the EVAP system. The monitors of fuel tank pressure sensor, whatever they're going to use, either voltage or inches of mercury or whatever they're going to use up there, they're going to monitor that one. And it monitors that for verified for a vacuum over a period of time. Now that's going to vary by the manufacturer. There's no set time that I've seen because everybody does it slightly different. So we're going to do that test. If it fails that test, then we have a large leak. A P455, I think, is a large leak. I might be wrong on that one, but there. The next thing we're going to do, if it fails that, or it passes that, depending on when we're looking at it, most of the time, all these systems are going to do one leak first, and then they're going to follow by a second leak test. So if you were looking at the charts, which they don't always give you that, if the weak vacuum test large leak fails, we go for a code. If it passes, we will now test it for a small leak because you're not testing it for the correct size of a leak. Once a predetermined vacuum of the weak vacuum test is achieved, doing the same process, they're going to close the purge solenoid, sealing off the system, the vacuum in it. And what they're going to be looking for is how long it takes to lose vacuum. Now, if the decay rate, which means we're going to lose decay rate, how fast we lose vacuum, if it's quicker or if it's slower than the test parameters, we're going to set a DTC port P0442 will set. Now, this is the same principle, basically, that you would use when you do an engine off natural vacuum. They're looking for a period of time that you have to maintain the vacuum in the system. Those are some things you're going to be looking at. So again, when you're doing this testing, make sure you understand how the test is run, how long it takes, because sometimes these tests on the engine off natural vacuum test can go over a period of a week before it will actually set and give you a code. So always make sure you understand how the test is run, what it's looking for, and how long it's run, and we can give your diagnosis a little bit better. So let's go over something else. Okay, we're going to do a service bay test on this particular vehicle. Now you're probably going to have the factory scan tool to do this test. Some of the aftermarket scan tools do not include this in their menus that you can do it. They have other tests you can do. So the first thing we've got is a service bay test, and we're going to hit number 1 on that one. And the first thing it says is start the engine for the test and press star to cancel, but we're just going to start the engine up. So they're starting a test, and it's doing a purge and vent circuit check. It's seeing if electrically they are working. So the next thing we're going to do, and your scan tool would be working you through each one of these tests, is we press 1 to run it. So it's testing the purge solenoid. Now we're doing the weak vacuum test. And you notice if we change it, you're going to see the vacuum change on the system up here, the voltage and everything else. Fuel tank pressure sensor, you're going to see the vacuum change here. Now we're going to do a small leak test. So again, they do one test and the other, as we said before. And if you notice, we're down about minus 8.6 on this, 8.4. We're looking at the system. Fuel tank pressure is 3.2. And we'll have the scan tool hooked up so you can watch this also at the same time. Now we're doing a vent restriction. Remember I told you about if we get a vent restriction, it would cause problems with the system. So now they're checking the vent restriction on it, which would be over here. And if I just press on here, close it down a little bit, see the pressure, there was a little restriction there when I pressed on it. Vents open, purge is doing about 10%. Purge solenoid leak test now. So we did the canister vent first, and we're doing the purge solenoid leak test on that one. Notice this is 0.9, and we're at fuel tank pressure sensor 1.6. Purge is at 0%. And the service bay test is complete. So this is things you do to have the computer double check itself to see if everything's working in the service bay. Good test to run for those EVAP problems you might run into. Okay, we have to set up the system to be able to test it. So the first thing we want to make sure is if you have the test port, you want to go over, take off the green cap. Remember, this is left-hand thread, so we're going to undo that, and then I'm just going to flip it down in the process and drop it on the floor. So here's the deal. The next thing we're going to do is attach our smoke machine up to the unit. Remember, it's left-hand threads for the Schrader valve, but right-hand threads for everything else. Now, to properly test a system, we're going to have to close the canister vent. So at this point, that should be closed. So if I'm just going to go ahead and hit this one when we close. Now, we're going to be looking at our smoke machine down here, and if there's a gauge here, there's a for 40 thousandths leak and a 20 thousandths leak. Well, this system should be a 20 thousandths leak, so we know what we're looking for. So I'm just going to turn the system on, and if I turn the system on with that, and we should watch the ball, and it should gradually go down. It takes a while. Watch it bounce a little bit. If it goes below the 20 thousandths leak here, that means we have passed. We have a sealed system. If it would be above that, we have a leak. We're going to have to do some testing. So we're going to act like we have to do some leak test, and we're going to apply smoke to the system next. Okay, if we're going to do a leak test with smoke, one of the things you think about, I just did the test up here because we did the test up here. I'm going to flip this thing over to smoke, all right? When I flip it over to smoke, what I want to do is go over and relieve the pressure in the system. You hear that noise that came out there? I'm going to relieve the pressure in the system, take this thing all the way off,
And what I'm going to do right now, if I'm looking at it, you notice I'm not applying it. So what I'm going to do is hit the button on here. And what it does is heat up the system in there, and it's going to create some smoke. So if we're looking at it over a period of time, that should be starting to build. If you look at it, it's starting to get already smoky a little bit in there, and we'll have a lot more going on. So the process, we have to look at it and do the process. Now I'm going to flip over to the other side real quick. If I'm looking at all the smoke, you notice the smoke is building up here. So the next thing you want to do, you look at the gas cap. You see the smoke coming out right there. First thing you want to do is close this thing off now. Make sure you get a good connection. And then you're going to go around the system to find out where the leak is. Now, I would tell you this might take some time because it's a plumbing system. You have to look at it. When we talked earlier, it's a big plumbing system on it. So if we do this process, you're going to go follow the lines down. Any connectors, especially, you're going to do that. But follow the leak down the lines all the way to the tank and the tank itself. The tank itself can leak. So you want to follow it down, use your light. Now the other thing is there are some smoke machines on the market that have a dye in it, all right? And that dye, the process of using the dye is to leave a residue as it leaks. So you would have an ultraviolet light, you'll have a pair of glasses that you're going to be needing, and you're just going to go down with that light up there. So I also have, my personal smoke machine that I have, which I haven't used in quite a while, has one of these. It also has another light that I can put a UV light out, for me so I can test the system. So there's different ways of doing it. So make sure that you have if it has a dye, also check it with the dye because it gives you another idea. Well, those real small leaks that you might run into. Now that's how you do the smoke machine and doing the testing. By the way, the biggest thing we're going to talk about again is you have to close the canister vent. And not all Scantools will allow you to do that. So keep that in mind. Sometimes you might have to manually close the canister vent. You might have to actually block it off to make sure you got a good, tight system when you're doing the smoke and checking it out. So let's go and, guys, just make sure you take your time and do this right. Do not rush this job. It takes time for it to build that smoke and that pressure in the system. Let's go. Okay, I mentioned this earlier in the system. If you do not have the test port, you're going to have to go to the tank. There is another alternate that you can do. You can actually lose a line going to the purge solenoid and put your smoke there. So what we're going to do is take this system, we're going to put our smoke here. We're going to be testing, well, we're going to try anyway. That'll happen to you guys every time, it always does. All right, so we've got our gauge up there. The first thing I'm going to do right now, we're going to be in smoke. I'm going to turn this on. And if we have a system looking at, we're building up here. Now, we're going to be able to put a code in here. And we put a fault in the system. Now, right now, because we got pressure, you can hear it. But if I'm looking at this, you're looking at the smoke's coming pretty good here. But if you look down below here, the tank itself has got a leak. We're looking at the process right down there. You can see the smoke being delivered right at this point here. And you can see a lot of smoke going in. And we have a leak down here toward the tank. You can see it down there with we're nice little setup, and we see it at the tank leaking. So that tells you that we have a leak in the system. Now I'm just going to go ahead and press 1 to clear the fault. Like I fixed it. And then what happens? You see the leftover smoke there? Wave. Just a little bit of smoke was left. We now have the leak fixed. The smoke will not exit. We should go back and be able to fix the car and deliver it to the customer. That's what we need to do with a smoke machine, to verify where the leak is, verify how big a leak it is, and be able to do the test. And then after you're done, you need to redo the smoke test to make sure there's no leaks.
Now, I want to thank you for watching this video. Hopefully you can go out and apply what you learned in the bay to fix these cars, get that monitor to run quickly. Now, also go out and see us on social media or check out other videos on our YouTube page. Thank you for watching. We'll see you again in the next one.